All right, guys, today we are learning about adding and subtracting unlike fractions. So if you don't have your book and your notebook out, go ahead and take those out. First off, of course, when you take your notebook out, go ahead and flip to your notes section. We have to fill in one vocab word today. So I'll give you a few seconds to do that. Go ahead and take your notebook out, flip over to your notes section, green on the left, your notes on the right. Okay, hopefully you have your notes out. You're ready to go. Okay, so here we go. Our one and only word, and you guys probably can guess it, it's unlike fractions. Everyone? Okay, so unlike fractions, the book says they are fractions with different denominators. Fractions with different denominators. Okay, so in your little box there, 1/2 and 3/4. All right. Obviously, 1/2 has the 2, 3/4 has the 4. It means they're unlike fractions. So that's all we're doing today. We're adding and subtracting fractions like this. All right. So if you haven't already done it, when we get going on our examples here, you're going to need, of course, your piece of paper for your homework and your book. So go ahead and take out a piece of paper and get your name, date, and period up at the top. Put your name, date, and period up at the top there. All right, and then once you get that done, take your book and flip over to page 129 for today. That's what our homework is on, 129. Okay, on page 129, hopefully your paper's ready to go. We are going to start with problem 28. Problem 28, and it is 6 6/7 minus 11 7/8. Okay, so in our lesson yesterday, whenever I was doing the problems, I showed you one method, and that was to separate your fraction from your whole number and then combine them back at the end. There's a little bit of carryover where we had to add the whole numbers at the end. When you're dealing with subtraction, you have to do some borrowing. We may have a chance to talk about that, but for today, I'm going to teach you a different method, and I mentioned it yesterday, and that is I'm actually going to convert these before subtracting them. I'm going to convert them to improper fractions. Okay, so that's going to be the first step today. So 6 times 7 is 42. 42 plus 6 is 48. And of course, we keep the denominator of 7. Bring down my subtraction sign. And what we have here is 8 times 11 is 88. 88 plus 7. Remember, our denominator stays an 8. So 88 plus 7, okay, is... sorry, it's early in the morning, so 88 plus 7 is 95. 95/8. Okay, so yeah, we're dealing with pretty large numbers here, but the time factor, it takes the place of doing some other stuff, like I said, like borrowing and worrying about other things. So here we go. Like any other time we're dealing with subtracting or even adding fractions with unlike denominators, just thinking ahead, we're going to go ahead and stack one on top of the other. Just organizing our work this way allows us to find those common denominators. Now, for the sake of doing this, you know, I can't divide 7 into 8 evenly to get a common denominator. I can mess around with them and get least common multiples, but because both of them are single digits, it's kind of my rule of thumb. If they're both single digits, I usually multiply them together. We're not going to get too large of a denominator. So 7 times 8, we can use 56 as our common denominator. Now what we have here is 7 times 8 is 56. And we're going to do the same thing to the numerator. So that's a pretty large number, right? So 48 times 8. Okay, you can just go over to the side, figure that out. 64. All right, 32 plus 6 is 38. So our our numerator is 384. And right here we have 8 times 7 is 56, so 95 times 7. And go over here to the side and use it like scratch paper. So 7 times 5 is 35. 63 plus 3 is 66. So we have 665 over 56. Now remember that this is subtraction. And now that we have common denominators, we can just bring the 56 down. Okay, but now we've got an issue here, right? We have subtraction. Now, this is where it gets a little tricky. You hopefully realize that this 665 has a negative value because it's subtraction. So when we're combining these, we have a positive 384 and a negative 665. So you can build your t-chart if you want. I just know that since they're different values, right, that we're going to go ahead and subtract them. The high sign, or the larger absolute value, is the negative 665, which means our answer is going to be negative. So I'm going to go ahead and subtract 665 minus 384. Do a little borrowing here. So 5 minus 4 is 1, 16 minus 8 is 8, 5 minus 3 is 2. So we have negative 281. Okay, now these are pretty large numbers to reduce, and we can try to reduce them, or we can change them back to a mixed number, which gives us a small a small fraction, so we can reduce that smaller fraction. It's a little easier to reduce sometimes. So it's totally however you want to, whenever I should say you want to reduce it. So I'm going to go ahead and divide bottom into top. I'm going to change it to a mixed number. So we have 56 into 281. And I'm going to go ahead and to divide, do a little long division. I'm going to cover my last one here and say 5 goes into 28 5 times. Okay, so if I try out 56 times 5, that's 6 times 5 is 30. 25 plus 3 is 28. Oh, that's almost perfect. So we have 56 goes into 281 5 times. I put it over the 1. We get 280. Subtract, get 1. And what this does is this tells me that 5 and 1/56 that I can't reduce to 1/56. Now, again, don't forget what we have is we have a negative here. So negative 5 and 1/56. Okay. Now, considering that we can't reduce that, that means that we couldn't reduce this. So realistically, if your answer is an improper fraction or as a mixed number, either way works. So there's our answer. So we're dealing with some big numbers today. That's why your homework isn't too long. Okay, so here's what I want you to try out, and I'll give you guys a little extra time on this. Okay, I'm going to have you guys try out on that page problem number 30. Problem number 30 on page 129. All right, I'll give you guys maybe up to a couple minutes here. So problem 30. Okay, go. Okay, so go ahead and turn to your neighbor and share your answer. Okay, so when we do number 30, what you should have understood was, of course, that's just a fraction. So we leave that alone. We don't have to convert anything there. We could just bring it down if we want. Okay, I'm going to go ahead and add. I'm going to convert this. 32 plus 1 is 33/4. I'm going to go ahead and bring it up over here. So what we have is we have a negative 5/6 added to 33/4. These are two small numbers. We can multiply them together, but you know what? Instead of doing that, I mean, I can see that both of them go into 12, so that's our least common multiple. So I can use 12 instead. Now, if you use 24 and reduce the bigger number at the end, that's okay too. You'll get the same answer. So 6 times 2 is 12. 5 times 2 is 10. Don't forget this is negative, right? And so what we have is we have 4 times 3 is 12. So 33 times 3 gives us 99. So because this is negative, that has a negative 10 value. Our denominator stays as 12. And then what we have is we have 99 and a negative 10. So what we're really doing is, the larger number, right? The larger absolute value is a positive. So I'm going to go ahead and subtract these two and get 89. And because our larger value is positive, our larger absolute value, that means our answer is positive. Okay, now again, I can sit here and I can try to reduce this 89/12, or I can of course do what we did up here. Doesn't really matter. I'm going to go ahead and I always like changing them to mixed numbers. That way we get the fraction part smaller and makes our division or our reducing a little easier. So if I go ahead and cover up the last digit, right, 1 goes into 8. So just try this out. 8 times 2 is 16. 8 plus 1 is, all right, too large. Okay, so what we've got is 12 times 7. Okay, and some of us may already know what 12 times 7 is. It's 84. So we go, 12 goes into 89 7 times. 7 times 12, like I just said, is 84. So we have 7 and 5/12. And 5's prime, I can only reduce it by 5 and can't reduce 12 by 5. So actually 89/12 is reduced. Or of course, if you want to write it as 7 and 5/12, that's fine too. So either one of those, and they're both positive obviously, so 7 and 5/12 or 89/12. Okay, next problem. All right, our next problem I want to do is problem number, let's flip actually over to page 130. On page 130, it's problem number 44. Okay, so we have a little twist in this one. So problem number 44 is negative 17 and 7/8. And we have minus a negative 17.9 in bar notation. All right, so we've got a couple of things going on here. First of all, I do see a double negative. I'm going to get rid of that. Now, here's the thing. Before I even worry about putting them into improper fractions or whatever else, I need to convert this to, and I mean, realistically, I can convert this to a decimal, but this is probably easier to convert this as a fraction, all right, to be able to solve this problem. So remember what we talked about. This is normally 9/10, but when it's a repeating decimal, it's actually instead of over 9, I'm sorry, instead of it's over 10, it's over 9. So what we have is 17 and 9/9, which is a little weird, right? Because what we've got here, if this is basically considered one whole, we're looking at 18. So I'm going to go ahead and bring down my negative 17 7/8 plus 18. Now, there's a lot of things we can do here. Okay, I can make these into improper fractions and solve. But what I notice is they're pretty close to the same. And some of you may already look at that and say, oh, I already know what that is. And you may. So here's what I'm going to do. And if this makes sense to some of you guys, just kind of thinking here. 18, if you're really good with fractions, you know that 18 is the same as 17 plus 1. Now, instead of 17 plus 1, here's how I'm going to represent 1. I'm going to represent it as 8/8. 17 and 8/8 is the same as 18. 8/8, right? The only reason why I made 8/8 is because now I don't even have to find a common denominator. I already have it. So here's what I'm going to do. I know that this is negative and that's positive. So, and they're already common denominators. So I'm going to go back to yesterday's lesson basically, and make it easy on myself. I'm going to go ahead and I'm just going to subtract these two, because that's what we're really doing, right? They're opposite signs. And when I subtract them, the larger one, of course, is positive. So my answer is going to be positive. And here's the funny thing. 17 minus 17 is nothing. I just have a fraction with a denominator of 8. 8 minus 7 is 1. And we end up getting 1/8. So that is our final answer. There's no reducing to that. So the whole point here is making sure on problems like this that we convert the repeating decimal. And remember, because the whole decimal is repeating, we can use this method that we talked about in class. So instead of 9/10, we put 9/9 because of the repeating decimal. So with that said, go ahead and I want you to try out problem number 40. Problem number 40 on that page. All right, you can go ahead and get started on that. Problem 40. Okay, 30 seconds. Go ahead and turn to your neighbor and share your answer. Go. Okay, so if you want to check this, here we go. We have a double negative. Should have made it into a big positive. There's actually no decimals here for us to convert on this one, so I'm going to go ahead and just change this back over to I'm going to change this back over to an improper fraction. So 5 times 3 is 15 plus 2 is 17, so we end up with a negative 17/5. Got to change this over. So 7 times 2 is 14 plus 4 is 18, so 18/7. I'm going to go ahead and stack these up. Negative 17/5 plus 18/7. Common denominator. I'm just going to use 35. I'll multiply them together and use 35. So 5 times 7, so 17 times 7. So that's 49. 7 and 4 is 11, so 119 over 35. Okay, remember that we can even move our negative over now if we want. And then this is 7 times 5, so 18 times 5 gives us 40. That's 9, so 90/35. Okay. So, looking here, bigger absolute value, right, is the negative. So our answer is going to be a negative. I am going to subtract these two, though, 119 and 90. All right, and so I could just say 9 and 11 minus 9 is 2, so that's negative 29/35. And you know what? That's actually a true fraction, right? It's not an improper. I should always look to reduce. And when I look to reduce, I realize that 29 is prime, so I can't reduce it by anything other than 29, and that obviously can't go into 35, so our answer, your answer, should have been negative 29/35. Okay. Now, I just want to get you started on one more problem. We're not going to do the whole problem together, but let's take a look at problem number 34. So flip back over to page 129, problem 34. All right, it's just a word problem. It says Sabrina wants to make a 17-inch necklace with a 3/4 inch bead, a 1 1/2 inch bead, and another 3/4 inch bead on it. What's the length of the remaining part of the necklace? Well, there's a number of different ways you can do this, but you know, if we're just writing down the expression, right? She starts with a total of 17 inches, and every bead she puts on is taking away the remaining amount, right? So you've just got 17 minus 3/4 of an inch, and then minus another 1 1/2 inch, and minus another 3/4 inches. And that's your answer. And you know, there's a number of different ways you can do this, right? You can, and actually some of this you probably can do as mental math, a lot of it actually, but knowing this, all right, we can just, if you're going to just work left to right, you can do that, okay, one problem at a time. But I would recommend taking a look at some of these, and since all of these are being taken off, you can combine those to see the total taken off, and then subtract that from 17 whole. So just a word problem. You'll have a couple of those on tonight's homework. So guys can go ahead and get started.